A. Form PD from this set of questions. So first of all, let us create a table. First of all, let us create a table. Here, the number of variables we'll write, we'll modify it and say number of independent variables, so that we know that we're talking about the number of independent variables. So first of all, let us look at the question. Z is equal to A I'll call this arbitrary constant, and I'll call this independent variables. I'll call this arbitrary constants. Now, let's come back to this. Let's come back to these are fixed constants. Fixed constants are specific numbers, specific constant. These are variable constant. Variable constant, for example, when you integrate and there are no limit, you used to put plus C. That plus C there is a variable constant. Now, pure variables are X, Y, Z. What I'm trying to say is that in any question that I give to you, apart from X, Y, Z, that are variables, pure variables. Any other letter that you see, they are variable constants. Or independent variable. Okay. So let's see how this is going to be. Looking at this question, what is the number of constants? What is the number of arbitrary constants? This is the only constant. We said X, Y, and Z are arbitrary variables. So the only constant is A. A is the only constant. Now the independent variables are X and Y. Let's forget about this Z. The independent variables, the pure variables. Okay. A, B, C, D, E, F, G, R to W, they are all variable constants. Only X, Y, Z that is. So this one is X, Y. So this is 1 and this is 2. There's one item here and there are 2 items here. Now, because this is 1 is less than 2, it means that the PDE that we are forming, we're going to get more than one PDE. We're going to get more than one equations. And 2. How many times are you supposed to differentiate? You're supposed to differentiate it once because the order is 1. So let's come back here. If I have Z is equal to AX plus Y, then this one tells you that Z is a function of X, Y. I'm supposed to differentiate Z with respect to X and differentiate Z with respect to Y. So we're going to have partial Z with respect to X. Here this will give me A. Then partial Z with respect to Y will give me 1. I normally call my question equation 1. And I call the differentiation equation 2 and equation 3. Now, this is my question, I call it equation 1. After doing all the differentiation, I also label it as part of my equation. Then let's go back to the heading. The heading says elimination of arbitrary constants. Arbitrary constants, not fixed constant. So 1, this is not an answer because there's an arbitrary constant A inside. This is not an answer because there's an arbitrary constant A inside. This is an answer because there's no arbitrary constant inside. So what we are going to do is that, but we know what A is, so we can go and put A inside here so that this arbitrary constant will vanish from this. Then this will be an answer and part of this will also be an answer. So you realize that there are 3 equations. The given equation is labeled as equation 1. The one that are differentiated, equation 2 and equation 3. This is an answer because there's no arbitrary constant inside. There's no arbitrary constant inside. This is not an answer because it's arbitrary. This one is not an answer because there's an arbitrary. So we can put A inside there so that arbitrary will vanish. So we can say that from 1 or put 2 into 1. So equation 1 becomes Z is equal to the Z, the X, A is this, then this is my X plus Y. So then, and the Z over the Y is equal to 1. So this 2 is my final answer. This 2 is my final answer because the rule says that you should have more than one PD, you should have more than one answer. These are the 2 answers. This is an answer because there's no arbitrary constant inside. This is not. So we put this inside it so that arbitrary vanishes. So this is our answer.